Okay, question 4 is about time of flight mass spectrometry. A sample of nickel was analysed in a time of flight mass spectrometer. The sample was ionised by electron impact. The spectrum produced showed 3 peaks with the abundances as shown in the table. Give the symbol, including the mass number of the ion that would reach the detector first in the sample. Calculate the relative atomic mass of nickel in the sample. Give your answer to 1 decimal place. Okay, so let's start with that. So, symbol of the ion. So they all have the same kinetic energy. So what determines how quickly or the time taken to get to the detector is going to be their mass. And the smaller the mass, the quicker they're going to move, the sooner they're going to reach the detector. So the symbol of the ion, now this is key, because if you write 58, that's not enough. He wants the symbol of the ion. So the symbol of the ion is, so it's nickel. We've just determined that it is nickel 58. And in order to be accelerated and detected, it needs to have a 1+ charge. Okay. Calculate the relative atomic mass of nickel in the sample and give your answer to 1 decimal place. So this bit here, this is where marks are often lost, and what I would suggest you do is give yourself a little reminder down here that when you've got your answer, you'll be so excited that you got your answer that you need to write it to 1 decimal place. So the formula for this, relative atomic mass, remember this is abundance multiplied by the mz. So 58 times 61 plus 60 times 29.1 plus 61 times 9.9, all divided by the total abundance, and because this is in percentages, that is going to be 100, so that's going to be one of the marks. Now, when you work this out, you will get an answer of 58.879. It's to 1 decimal place, which means that that is here, because this here is above 5. I need to round that up. So my final answer down here is 58.9. Okay. So part B. 137 barium ion travels through a time of flight tube mass spectrometer with a kinetic energy. So the kinetic energy of that. The ion takes this amount of time to reach the detector. We're given the kinetic energy formula. We need the mass in kilograms. And we've got Avogadro's constant here. So we're asked to calculate the length of the flight tube in meters. Give your answer to the appropriate number of significant figures. So let's just have a look at the significant figures first. So there are 3 significant figures here. There are 3 significant figures here, 4 significant figures here. And remember, we can only be accurate to the least number of significant figures. So again, where I'm going to write my answer, I'm going to give myself a little reminder that needs to be to 3 significant figures. A lot of marks are lost through people not finishing that off by reading the question. So let's work it through. So I'm asked to calculate the length of the flight tube. Now that is going to be distance. Now what do we know formula-wise with distance in it? So we know that velocity is distance divided by time. So distance is going to be equal to velocity multiplied by time. So let's have a look at what we've got in the question. So I'm given the kinetic energy and I'm given the time. So I've got time, but I haven't got velocity. So I've got that, but I haven't got velocity. So I need the other formula that has got velocity in. So that's going to be the kinetic energy formula. So kinetic energy formula is mv squared over 2. So I need to get v on its own. So let's just follow this through. So v squared is equal to, so multiply both sides by, I've swapped it around as you can see. So if I multiply both sides by 2, the 2's cancel, so it's going to be kinetic energy times 2, and divide both sides by m, so that cancels out on the one side, and that gives me that. And then to get rid of the square root here, the squared here, I need to do the square root of that. So over here, my velocity is equal to the square root of 2 times the kinetic energy divided by the mass. So again, that's my working out done. Let's have a little look. So what have I got in the question and what am I short of? So in the question, I've got, let's just have a look. So I've got kinetic energy, that's this bit here. Obviously I've got 2, but I haven't got mass. So now I need to work out the mass of this, which is using this value here. So the mass is equal to, right, so the 137 is 137 grams per mole. So mass needs to be in kilograms. So the first thing I'm going to do is divide by 1,000, which is times 10 to the minus 3. And that's the mass of 1 mole. So that's the mass of 6.022 times 10 to the 23 in kilograms. So to get the mass of one of those, 6.022 times 10 to the 23. Okay, so when I work that out, so all this is going to follow through now. So working my way back down, so that's going to be 2.275 times 10 to the minus 25 kilograms, and there will be a mark for that. Plug in all of the values into this, so 2 times the kinetic energy in the question is 3.65 times 10 to the minus 16, all divided by what I've just worked out above, 2.275 times 10 to the minus 25. Don't forget to square root. Again, that's another thing that is often forgotten. And then that gives me a velocity of 56646.29661. So the distance is equal to that. So that's my velocity. So 56646.29661 times time in the question, 2.71 times 10 to the minus 5, which equals 1.54. Just checking that I've got that to 3 significant figures. 1.54. So where are the marks? So the marks are for rearranging that formula, obviously, for the correct answer, for working out the velocity, for rearranging the formula for the velocity, and one for working out the mass. And again, it's one of those scenarios where if you just plug all these values in your calculator and hope for the best, you could get all 5, but you could get none. If you show your working out and lay it out stage by stage, as I've shown here, even if you get the answer wrong, you could pick up 3, 4, 5, well, 2, 3, 4 of the marks.